This video is going to have a look at an example of solving quadratic equations using the Null factor law, where you need to factorize the expression first. So looking at the Null factor law, if we are multiplying two terms together, so a and b, and the answer to that is 0, then we know that either a has to equal 0 or b has to equal 0, because that is the only way we can get an answer of 0 when we're multiplying two terms together. So to use the Null factor law to be able to solve a quadratic equation, first we'll need to factorize the equation. Sometimes the question will already be in factorized form and you won't need to factorize. Other times it will give you the full expression and then you've got to go ahead and factorize it before you can apply the Null factor law. Once you have factorized it, then you can apply the Null factor law to determine the possible solutions, remembering that you're going to get more than one value of x. So your answer is going to have a couple of different values of x. So let's have a look at an example of how can we apply the Null factor law. So the example, we want to solve the equation x squared minus 3x is equal to 0. So the first step we need to do to be able to solve that equation and find our values of x is going to be to factorize that expression. So x squared minus 3x, and I can see that I've got a common term of x in both of those terms. So I can go ahead and remove that common term, and I can do that by dividing both of my terms by x. So x squared divided by x is going to equal to x. 3x divided by x is going to equal to 3. So it's going to be x minus 3. And then outside the bracket is going to be my common factor of x, which is equal to 0. So now my equation is x minus 3 is equal to 0. And I can apply the Null factor law to that equation. So when I'm multiplying those two terms together, remembering there's a multiplication sign, so it's really x times x minus 3 is equal to 0. One of those terms is going to have to equal to 0. So either x is equal to 0 or x minus 3 is equal to 0. So one of my values of x is going to equal to 0. And then to work out what my other value of x is going to be, x minus 3, to get x by itself, I need to plus 3 to both sides. So therefore, x is going to equal to 3. The solutions to the equation x squared minus 3x is equal to 0 is going to be x is equal to 0 or x is equal to 3. So if I was to graph that onto our Cartesian plane, my x-intercepts would be at 0 and 3. So let's have a look at what that looks like. So looking at a graph of the equation x squared minus 3x is equal to 0, I can see that my x-intercepts is at 0 and 3. So let's have a look at a second example. So in the second example, we want to solve the equation x squared plus 15x plus 36 is equal to 0. So before I can apply the Null factor law, I need to go ahead and factorize that equation. When I'm factorizing three terms, I start off by looking for factor pairs that multiply to give me 36. The factor pairs will be 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. After you have the factor pairs, you're then looking to see which ones of those pairs are going to add up to give you a positive 15. So 1 plus 36 is going to equal to 37, 2 plus 18 will equal to 20, 3 plus 12 will equal to 15, 4 plus 9 is equal to 13, 6 plus 6 is equal to 12. So going through having a look, I can see that 3 and 12 are going to add up to give me 15. So my factor pair that I'm going to use is positive 3 and positive 12. So writing it in factorized form is going to be x plus 3, x plus 12 is equal to 0. So now that I've got it in factorized form, I can go ahead and apply the Null factor law. And remembering that in between my brackets, it's going to be a multiplication sign. So when I'm multiplying, either x plus 3 is going to equal to 0, or x plus 12 is going to equal to 0. So now I can solve each of those options. So x plus 3, to get x by itself, I need to subtract 3 from both sides. So x is going to equal to negative 3, or x plus 12 is equal to 0. To get x by itself, I need to subtract 12 from both sides. So x is going to equal to negative 12. So my solutions for x squared plus 15x plus 36 is equal to 0 is going to be x is equal to negative 3 or x is equal to negative 12. So when I go ahead and graph that onto a Cartesian plane, I would expect my x-intercepts to be negative 3 and negative 12. So let's have a look to see whether we are correct. So I can see my graph for x squared plus 15x plus 36 is equal to 0, and my x-intercepts are going to be negative 3 and negative 12. So that confirms my solution is correct. So there were a couple of examples of how we can solve quadratic equations by factorizing and then applying the null factor law.